Okay, let's continue with the lecture. Okay, so today the plan is to finish the remaining parts from chapter 3, and then we're going to start with topic number 4 today. Okay, because before that, let me share you this part. Okay, I'm not sure whether I've shown you this one or not. Okay, but so this is the breakdown in your the breakdown for the marks. Okay, for topic 1 until topic 10. Okay, so we're gonna have 3 tests. Okay, the first test, which is supposed to be due by latest by early next week. Okay, to which covers topic 1 to topic 3, and then topic 4 and 5, 20%, 6 and 7, 20%. So the 3 tests will cover 65% of your total marks, and then the remaining 3 chapters will be divided into 2. Okay, chapter 8 and 9 will cover assignment 1, group assignment 1, and topic 10 will cover group assignment number 2. Okay, both assignments will contribute to another 35%. Okay, so that will be the division of your total marks. Okay, that make up for the 100%. Okay, so we have so we're gonna finish topic number 3 on the so we covered last week, okay, on the mean, standard deviation, and variance, okay, using sample and population formula. Okay, and then today we're going to finish the remaining components from chapter number 3. So this is what we did the last 1 week. Okay, just a heads up, okay, the formula that or the website that you so I gave you 2 links in the OL, okay, to perform the online calculation for mean and standard deviation and also variance. Okay, but I do notice that the other the website on this one on the social science statistics, okay, the formula for the standard deviation, okay, although you have the population and sample options here, but the formula remains the same for population and sample. So to calculate standard deviation and variance, okay, you need to, if you want to use this online tool, okay, so you need to use the second link, calculator.net, okay, for the standard deviation. So for this one, you can see that also it is divided into 2, population and sample. Okay, so for population, we only divide by n. Okay, but if you want to use for the sample, okay, the formula is divided by n minus 1. Okay, so this is the difference between sample and variance. Sorry, sample and population standard deviation, which is what we covered last week. Okay, so dividing by n minus 1 gives you a sample formula. Okay, but dividing by n gives you the population formula. Okay, so if you want to use that online calculator, okay, use the calculator.net, okay, to solve. Or else you can just use your calculator, manual calculator, okay, to perform the calculation. Okay, so we have covered almost all, okay, but the remaining 2 parts, okay, or 2 theorems in chapter 3, which describe also your data, okay. So overall, what we have discussed, okay, from the very beginning, okay, so the idea is for chapter 3 is to when you learn about mean, median, and mode, okay, basically about the focus on the central tendency, okay, the location of your data, which data is located in the middle with the highest frequency, okay, with the number in the middle, which is the median, okay, and also we covered on the dispersion, okay, how spread of your data, the spread of your data, whether your data is grouped together around the same numbers or are scattered, okay, meaning you have some low numbers, some medium values, some high values. So that is the purpose of variance and standard deviation. Okay, so the last 2 concepts that we're going to look at, which is the Chebyshev Theorem and also Empirical Rule. So what these 2 concepts or theories is used, especially for the second one, Empirical Rule, is basically also want to highlight, okay, how many percent of your data is within certain value. Okay, so if you want to explain to someone 95% of my data is within what range, okay, 99% of my data is within what range. So that is the purpose of these two concepts. Okay, so you may not be able to appreciate these two theorems now, okay, at this stage of your study. Okay, but once you start learning on basic econometrics, okay, and also applying the concept of regression analysis, and also in your project paper later on. Okay, so these two concepts, especially on the empirical rule, will be applied again. Okay, so first let me discuss what is Chebyshev theorem. Okay, so you can read this part in more detail in the ebook, in the PDF file. Okay, but basically what the Chebyshev theorem means is that first, of course, is the formula. Okay, for any set of observations, whether it's sample or population, we're talking about the proportion. Okay, the percentages of your data lie within k standard deviation of the mean. So we already discussed what is standard deviation, which is the measure of the spread of your data, the dispersion. Okay, so basically from last week we learned that the higher is the standard deviation, meaning that your data is very spread. Okay, so meaning you have data at low value, at middle value, and also at high value. Okay, but if your standard deviation is very small, okay, so that suggests that your data is clustered or grouped around the same numbers. So you check again our lecture from last week, okay, when I use some example to illustrate what it means by low standard deviation in your data, okay, versus when the data has high standard deviation. So again, we can also apply these two theorems, okay, to illustrate how many percent of your data is within how many standard deviation. Okay, because we know that a low standard deviation means your data is grouped around the same numbers. Okay, so Chebyshev theorem suggests that for any set of observation, okay, the percentage or the proportion of the values that lie within k standard deviation is at least 1 minus 1 over k squared, where k is a constant greater than 1. Okay, so k represents the value of standard deviations, the value within k standard deviation. So basically, if we put, let's say k is 3.5 within 3.5 standard deviation, so that means that up to 92% of our data is within 3.5% of 3.5 standard deviation. Okay, so the formula is quite straightforward. Okay, 1 minus 1 over k squared. Okay, so where k represents your standard deviation value. Okay, so 1
Doktor,
over, yes.
Doktor tunjuk slide kau.
Slide. Oh, you
Kami nampak kalkulator net ni.
oh wait, let me share. Wait. Okay. Okay, sorry for that. Okay. So yeah, the Chebyshev theorem, right? So you have your slide with you. So basically what the Chebyshev theorem, okay, the formula is 1 minus 1 over k squared. Okay. And then so when if your k is 3.5, meaning that the standard deviation is 3.5. So we are talking about 92% of the standard of your data, okay, or almost more than 90%, okay, or 90%, 92% to be exact, of our data lie within 3.5 standard deviation. Okay, so that is what Chebyshev theorem is. So it is very similar to the second theorem, which is the empirical rule, okay, which describe similar concept with Chebyshev theorem. We want to know how many percent of our data is within how many standard deviation. Okay, so Chebyshev theorem formula is 1 minus 1 over k squared. So if you put standard deviation around 3.5, so we know that up to 92% of our observations is within 3.5 standard deviation. Okay. So, and the second part, which is the empirical rule. Okay. Again, empirical rule applies in, so we learned in chapter number 2 before, okay, if you recall, on the skewness. Okay, zero skewness, positive skewness, and negative skewness. Okay, zero skewness when the mode, mean, and median is in the middle. Okay, or and we also call this as a normal distribution. Okay, where the left tail or the distribution is symmetrical. So you can cut the graph into half. So the area on the left will be the equal, the same size of the area on the right. Okay, so that is what it means by empirical rule. Okay, so empirical rule applies on a zero skewness distribution or a normal distribution. Okay, so for a symmetrical bell shape, okay, symmetrical means, okay, the area on the left will be equal to the area on the right. Okay. So that is what symmetrical bell shape. So it looks like a bell. I mean, if you logic lah, okay. A symmetrical bell-shaped frequency distribution. So you have three most common percentage, okay, 68%, 95%, and also 99%, or almost all, okay, more than 99%. So three, okay, 68, 95, and 99. So 68 is within plus minus 1 standard deviation. 95 is within plus minus 2 standard deviation. Okay, and 99% is within 3 standard deviation. Okay, so previously in Chebyshev theorem, okay, 92% is within 3.5. Okay, meaning that this is the formula that that Chebyshev theorem states. Okay, so 92% of the observation. Okay, so let's say if you have 100 sample, okay, there are 100 students. Okay, 100, your n is 100. Okay, the number of items or the number of sample, let's say 100. Okay, so let's say 100 students. So 92% mean 92 students, okay, 92 students. So you're talking about, if you want, if we use this concept, so let's say we want to say that 92% of the students prefer to study face-to-face, meaning that go to actual classroom. So for example, that is a simple survey. Okay, so but if you want to express in terms of Chebyshev theorem, so we can say that is at least how many percent is within plus minus 3.5 standard deviation of the mean, meaning if we talk about if we measure 3.5 plus minus 3.5, we are talking about up to 92% of our sample, of our data belongs, is within 3.5 plus minus standard deviation. Okay, but when you apply the empirical rule, okay, so empirical rule has three most common percentages. Of course, this can also change. Okay, but the three most common one is 68, 95, and also 99. Okay, and 68 is for plus minus 1 standard deviation. 95 is within 2 plus minus 2 standard deviation, and almost all, meaning 99%, is within plus minus 3. Okay, the Chebyshev theorem in the previous slide, 3.5 standard deviation is around 92%. Okay, so but for empirical rule, plus minus 3 is around 99%. So if you compare empirical rule and Chebyshev theorem, okay, so 3.5 is around 92%. 3.5 plus minus, but under empirical rule, 3 plus minus 3 is almost 100% or 99%. So slight difference, okay, but both are about explaining how much of your data is within certain value of standard deviation. Okay, so again, because your standard deviation is the measure of the spread of your data. Okay, so the bigger is your standard deviation that you use. If you can, so if you want to imagine what is the purpose of knowing whether it is 1% standard deviation plus minus 1 standard deviation, or plus minus 2 standard deviation, or plus minus 3 standard deviation. Okay, so if you imagine that if you okay, let's say if you are traveling from point A to point B. Okay, so let's say you are traveling from one place to another place. Okay, from point A to point B. Okay, so and somebody, let's say if you are telling someone, okay, I will be, so let's say you are, you expect that, okay, so let's say in normal time, the traveling time from point A to point B is 1 hour. Okay, so that is under normal time, meaning no traffic jam, good road condition. Okay, not many cars on the road. So the time you take to travel from point A to point B is 1 hour. Okay, okay. So let's say if you depart at 9 a.m., so you are expected to arrive at 10 a.m. Okay, if the traveling time is 1 hour. I mean, nowadays when you use GPS, okay, so you can almost measure your arrival time. Okay, quite accurate. Okay, if the condition does not change. Okay, no traffic jam, no accident, or whatnot. Okay, so let's say from point A to point B, 1 hour. So if you travel at 9 a.m. to you will expect to arrive at 10 a.m. So meaning that under normal condition, you are 100% sure. Okay, 100% sure lah. Okay, that you're gonna arrive at 10 a.m. under, if you look at your GPS, okay, no traffic jam, no accident whatsoever. Okay, so if somebody asks you how sure are you, okay, then you will say that I'm 100% sure. Okay, but then if that let's say there is some slight traffic, some increase in the number of traffic, okay, in the number of vehicles on the road. Okay, maybe because there is, I mean, if you're traveling, let's say during working hours. Okay, so for example, then that this 1 hour might, so you cannot say for sure that you will arrive at 100% sure that you will arrive at 10 a.m. Okay, but maybe you are 99% sure. Okay, you are 99% sure, meaning that if you explain to someone, I will reach point B. Okay, but I'm 99% sure that I will reach at point B at around 10 a.m. Okay, so because when you look at the traffic, okay, so you're not 100%, but so 99% means that in terms of the distribution, okay, you are willing to account for at least plus minus 3 standard deviation from your traveling time lah. Okay, meaning the bigger is your standard deviation, the more data, I mean the more sample, I mean the more observations you will cover. Okay, so and then let's say if you're less sure, okay, so let's say we go up to 68% because of there is a traffic jam, there is accident, and let's say it's raining heavily, so cars are traveling very slow on the road. So let's say you are down up to 68%, okay, of your confidence. I mean, of your certain. I mean, so in terms of if you are less sure, let's say, I mean, your confidence level, let's say, drop. Okay, so let's say 68% now, rather than 100% from the very beginning. So in terms of your when you reflect this in terms of your data, of course, this example may not be the best example. Okay, but when you talk about data, the bigger is the value of your standard deviation that you are willing to take, the more data you will cover in your observation. If you're willing to take less standard deviation, okay, less data will be covered. If you imagine standard deviation is like the margin of error. Okay, so the smaller the margin of error, the smaller is the range of your data. If you are willing to take higher margin of error, the more data you will cover. Okay, I think that is quite simple to understand. Okay, so if you are willing to tolerate higher margin of error, okay, meaning you are going to so let's say if somebody asks you how sure are you are going to get grade A, okay, grade A for this subject. So if you are willing to let's say account for more margin of error, meaning okay, you take into account many issues in your let's say you already taken into account all of your assignments, your workload, okay, meaning you have think of all the problems that you face this semester, okay, and you are prepared for all the things that you need to do, okay, how many hours you need to allocate for your study time, for your assignment, okay, and then the problems of your internet connection and whatnot. So if you are willing to risk, I mean to take into account all of that, then maybe your chance to get A is much higher lah. Okay, so of course, again, as I mentioned, okay, the concept of empirical rule, you may not be able to appreciate or to understand this at this stage, okay, but in terms of data, okay, the simplest way I can describe this is this concept is about the margin of error. Okay, so the bigger is the margin of error, the more data you are going to cover in your distribution. Okay, so that's why 60% of your data, if you look at this range between left and right, okay, so this distance only covers 60%, meaning because you are only willing to tolerate up to one ±1 standard deviation. Okay, but if you are willing to tolerate up to 3 standard deviation plus minus, you are going to cover more observations, okay, in your data. So in your textbook, okay, in on page 80, okay, of course in this slide there is no example given, okay, in terms of the calculation. So you can refer to your ebook on page 80, okay, on this part here, okay, for empirical rule, okay, for Chebyshev theorem. Because the formula is pretty straightforward. Okay, so let's say if you're talking about this one, so in Chebyshev theorem there is no data that you need to kick in. So you just based on the formula 1 minus 1 over k squared. So if k is 3.5, so you're gonna get 92% of your data belongs to this. So meaning this data actually is not being, let's say if you look at this example here, okay, you are given the mean, and then you are given, so let's say if, so the mean is 51.54, standard deviation is 7.51, at least what percent of the contribution lie within 3.5 standard deviation. Okay, so you can, so what this the Chebyshev theorem only measures how many of your what is the proportion of your data. Okay, so you can only tell how much is the proportion, but you cannot see for sure what is the range in your data. Okay, but for empirical rule, okay, you can also calculate what is the range of your data that fall within that plus minus 2 standard deviation 1 or 3. So for example, here you are given the mean value of this as 500, okay, and then the standard deviation is 20, okay, using empirical rule, okay. So about 68% rentals are between 1 to amounts, okay. So you know that 68% is within 1, 95% is within plus minus 2, almost all or 99% is within 3. So if you look at this simple solution here, okay, so about 68% is between plus minus 1. So the formula is simple, okay, x bar plus minus 1 multiplied by your standard deviation. So 500 is the mean, plus minus 1 multiplied by s is 20. So meaning that 500 minus 20, you get 480. 500 plus 20, you get 520. So the range is between is within 480 to 520 for 68%. Okay, so if you refer to this slide just now, okay, so 480 is like the area on the left, I mean the value on the left side of the distribution. 520 will be similar to 110 here. So 90 is like 480. 110 is similar to 520. Okay, because you are talking about the range from left to right. okay, because this is a symmetrical distribution. Okay, so the value, the actual value here, okay, this is the smallest value, and this is the highest value. It's just like the histogram that you plot, okay, but rather than having a box, so we take the smooth line plot here. Okay, so the lowest value up to the highest value. So here up to 60% is within 480 up to 520. Okay, because 60% is within plus minus 1. Okay, similarly 95 is within plus minus 2. So 500 plus minus 2 multiplied by 520. So you're gonna get the lower, I mean the minus side, you're gonna be 460 up to 540. Okay, so 500 minus 40 and 500 plus 40. So 46050. Okay, so if you refer to this, so 95%, so this 80 value is similar to ours 460 here. Okay, so 540 is similar to 120. So this value is 540. Okay, if we want to put this value in this diagram here that represent 95%. Okay, and finally plus minus 3. Okay, you can see here, so you can calculate this on your own. Okay, what is the value? Okay, so that's about it. Okay, the empirical rule. Okay, so for empirical rule 1, 2, and 3. So 1 is 60%, 2 95, 3 is 99%. Okay, or almost all. Okay, so for empirical rule, you can know what is the lower and the upper limit. Okay, the lower boundary and also the upper boundary based on the simple formula x bar plus minus x bar plus minus 1, 2, or 3 standard deviation. Okay, so this is the way for you to determine what is the range that lies within 68, 95, or 99%, or 1 standard deviation, 2 standard deviation, or 3 within plus minus 3 standard deviation. Okay, so that's it on this empirical rule. Okay, so overall, okay, so I just want to remind you again, okay, on this on the calculator part, okay, if you want to use the online calculator to calculate the mean, the standard deviation, sample, and also population, okay, so please use the calculator.net instead of the social scientific calculator. So there are 2 links which I gave to you. Okay, so the one that we did last week was the other link. Okay, but when I tested sample and population, the value come out the same. Okay, so if you need to calculate sample standard deviation, okay, and also population standard deviation, so use this one instead. Okay, so for example, you can see sample, you get the value to be 5.23. Okay, but then if I choose population, you're gonna get the value as 4.89, because the denominator now is only divided by n. Okay, but for sample, okay, as we know, it's divided by n minus 1. So of course the value will be slightly different. Okay, so I think that's it for chapter number 3. Okay, because the plan is that chapter 1, 2, and 3 should be covered within 1 week of lecture. Okay, 1 week. So this week is our 4th week of lecture. Okay, so we're gonna start on your chapter number. Okay, so we already finished 1, 2, and 3. Okay, for chapter 2, we don't really discuss that much. Okay, apart from the assignment that you sent to me. Okay, so for test number 1, okay, or for quiz number 1, okay, that will cover chapter 1 to 3. Okay, so again, it contributes 25% of your total mark. So it's higher than the other 2 tests. Okay, so please make sure that, okay, so for the calculation part, so we only cover for chapter number 3 for the calculation. Okay, for chapter 1, there is no calculation involved. Chapter 2, I don't really stress. I mean, there is no specific question on chapter 2 because we only apply in your Excel, okay, to see how you're gonna plot the histogram and whatnot. Okay, so so the plan is so today is Sunday. Okay, so earliest for the test number 1 should be by next Sunday. Okay, so maybe I will do it on Sunday or Monday. Okay, so I will open the test for several hours. Okay, and then but I will update you guys on your WhatsApp. Okay, the test is the questions are already ready, okay, in my system, so it's just a matter of setting the time. Okay, so okay, so just so you can start revising chapter 1 and 3 mainly. Okay, so for chapter number 4, we're going to cover on probability distribution. Okay, so I think I did mention earlier in the first week of lecture. Okay, in your syllabus, okay, from chapter number 5 onwards, okay, the focus is mainly on this normal distribution. So from topic number 5 until topic number 10, okay, especially topic number 9. So the focus is on normal distribution or under the heading of continuous. So 5 until 10 are all dealing with continuous distribution. Okay, but for chapter number 4, okay, it's a standalone topic, meaning we only cover discrete distribution. So discrete, the opposite is continuous lah. Okay, so discrete we only cover in chapter number 4. So only one chapter we're going to cover discrete. Okay, but for continuous, okay, the rest of the syllabus are all related to continuous distribution. So 5 is just the introduction, and then the rest will be applying the concept of continuous distribution. So for chapter number 4, okay, the focus will be in for this remaining topic 4.4 and topic 4.5, binomial and Poisson distribution. Okay, if you look at your ebook, okay, at the end of the book, okay, so you're gonna have this the table for normal distribution. Okay, you also have this table for areas under the normal curve. So this is, and then okay, so you can, yeah, so for chapter 4, okay, either you can use manual calculator or you can also use the online calculator, okay, to solve for the binomial and to calculate the binomial distribution and also Poisson distribution. Okay, but for today, I'm just going to start briefly on this 4.1 until 4.3. Okay, so I'm not going to spend a lot on this the first 3 topics. Okay, but rather than the focus will be on the remaining 2. Okay, so because your even the test questions that you're gonna have for test number 2 later on. Okay, so topic 4 and 5. So the topic 4, okay, the one that we're gonna cover today, and also this week and also next week, the focus will be mostly on binomial and Poisson. Okay, so the test that you will have for topic number 2 also, when it comes to chapter number 4, mostly will come from these two items, okay, binomial and Poisson. Okay, so let me discuss. So this is chapter number in the textbook. This is chapter 5. Okay, so in your syllabus, this will be topic number 4. So this is according to what your book, the coverage in your textbook. Okay, so under discrete distribution, so what it means by discrete, okay, we already discussed earlier in chapter number 1. Okay, discrete means you can count 1, 2, 3, 4. Okay, it doesn't involve decimal places. Okay, but continuous, okay, distribution, the event that involve perpuluhan or decimal places, 1.1, 1.2. So discrete means the event that only takes exact number. Okay, 1, how many times do you go to class? Okay, so you can see I go to class once a week or twice a week. Okay, there is no 1.2, 1.3. Okay, so, but what is your CGPA? Okay, what is the probability of getting 3.1? So in terms of if the data can take continuous number or decimal places, so that one will fall under continuous distribution. Okay, so for discrete, okay, the focus for discrete will be again, okay, binomial and Poisson, because these are two distributions that can only take exact numbers. Okay, what is the probability that that you will have, let's say, that you will own one house, okay, when you, or you can buy two houses before you retire. Okay, so maybe you want to buy one house also is already costly. So to buy two houses, maybe the probability will be much smaller. So, but you cannot say the probability of buying 1.3 houses. Okay, there's no such thing as 1.3 for exact number like bilangan rumah, number of houses and whatnot. Okay, so that is for binomial, and so we're going to cover briefly what are the characteristics of probability distribution. Okay, the difference between discrete and continuous. Okay, I already gave to you the basic idea what is discrete, what is continuous. Okay, and then compute the mean. Okay, but of course, this is just going to be very brief. Okay, so the focus will be on the remaining two here. Okay, so what is the probability distribution? Okay, so for the rest of the syllabus, okay, not only chapter number 4, okay, although the distribution, the table that the way the distribution is being displayed might be different, but the concept remains very similar. Okay, probability distribution is a listing of all outcomes, okay, of an experiment and the probability associated with the outcome. Okay, so the word distribution is a list, okay, or you can list down what are the probability that of all the possibilities, okay, or the probabilities if you do an experiment. Okay, so and then you take into account all of the possible outcome you put in the table. So that is what we call a probability distribution. Okay, and of course the simplest one will be okay, when you toss a coin. Okay, so in this example you toss the coin 3 times. So of course this shilling is not a Malaysian shilling, so this is from US. Okay, but whenever you toss a coin, let's say if you want to start the game, okay, the referee wants you to choose whether you want to start first or second. Okay, so is the common one is head or tail. Head is usually the picture of someone or the logo of someone. Okay, like in Malaysia, the head is usually the symbol of something. Okay, like the picture of Chongka or okay, or those kind of things. Okay, but in the US, the head is actually the someone's face lah, or the head of someone popular, okay, or significant. Okay, and the tail will usually is the value of the shilling, the 10 cent, 20 cent, 50 cent. Okay, so when you toss the coin 3 times, there's possibility of number of hits appears. Okay, so whether you get 0 out of 3 times, you do not get the hit. Okay, only the tail. Okay, 1, 2, or 3. So this is a simple idea of a probability distribution. So when you toss the coin 3 times, okay, you might get the first time you get tail, and tail. Tail means the back of the head, meaning the one that shows you the value of the coin. Okay, 5 cent, 20 cent. Okay, whether you get 3 times tail, meaning 0 hits, and or some other combination. Okay, tail, head. Okay, and then you calculate what is the number of hits from each of the possible outcome. Okay, so when you account for all possible events, you put in a table. So that is what we call as this probability distribution. Okay, so first the characteristics. Okay, the outcome must be between 0 and 1. Whenever you talk about probability or the proportion, okay, you cannot exceed 1. Okay, the outcome is mutually exclusive. Okay, what it means by mutually exclusive event. So you may not be using this term a lot, okay, but at least in terms of statistics, okay, the term mutually exclusive is that the event of okay, for example, like this one. Okay, when you toss the coin 3 times, okay, even though you get fail the first time, okay, does not mean that you will guarantee to get hit the second time. So what happened in the first time will have no influence on the outcome of the second time when you toss the coin. The same as the third time. Okay, so meaning that what happened in the first time does not influence the outcome of the second, and the outcome of the second will not influence the outcome of the third. So everything is random lah, nasib lah. Okay, so just like when you go, if you predict what is the color of what is the brand of the car that you see on the road. So let's say you are standing on the road, okay, on the roadside, okay, and then you want to guess, okay, the next car will be model Honda, the next one will be Proton, the next one will be Pro Duo. So just because you get that you see a Proton the first time, there is no guarantee that the second time will be Proton as well. Okay, so what happens the first will not influence the second time. So that is what mutually exclusive. Okay. And then when you the sum of all the probabilities will always be equals to 1. You cannot get more than 1. Okay, so probability will not exceed 1. Okay, it's between 0 to 1, 0.1, 0.2, 0.9. Okay, but you will not get more than 1, 1.1. Something wrong with your calculation if you get more than 1. Okay, so the case that we got just now, the number of hit that you get. Okay, so how do you get 1/8, 3/8, 3/8, 1/8 here? Is you just refer to this one. 0 hit, 1 out of 8 possible time. Okay, but if you get hit 1 time, 1, 2, and 3. So 3 out of possible 8. So that's why you get 3 lah. Okay, the same thing here. You get hit 2 times, also 3 times. 1, 2, and 3. So twice appear 3 times. Okay. So that's how you convert this into probability outcome, and the sum will always equals to 1. So that is probability distribution. Okay, so how you do an experiment, okay, as simple as tossing a coin, okay, and then you construct a simple distribution table, okay, by I mean you try to see what are the different possible outcomes, okay, from that experiment, and convert that into a simple probability distribution table. Okay, so that is probability distribution. So random variable, okay, a quantity resulting from experiment that by chance can assume different values. So the word random is rawak lah, meaning okay, whenever you do an experiment, okay, whatever outcome is random. Okay, so if you play a game like Monopoly, okay, or whatever board games, okay, and you have a dice or two dice, okay, and you throw the dice and you want to see okay, you want to see what are the numbers that appear on top of the dice, dadu lah, dadu, and you want to see what numbers do you get. So tossing the dice, okay, 1 times, 2 times, okay, the number that appear on top of the dice is totally random. You cannot influence the outcome. The first time you throw, you get 6, 6. Second time you will also get 6 and 6. So there is no so that is what random variable is lah. Okay, possible. So it's the same thing here. Okay, so these are all the possible events that when doing an experiment by tossing the coin 3 times. Okay, so again, the focus of our chapter number 4 will be these two. Okay, discrete and continuous. Chapter number 4, we have 2 distribution, binomial and Poisson distribution. Both fall under what we call discrete distribution. Okay, because the event can only assume discrete number. Okay, discrete again, exact numbers, 1, 2, 3, 1, 2, 3, 4, 5. Okay, so whenever you do an experiment, the number of events can only take exact numbers, okay, or clearly separated values, 1, 2, 3, 4. Okay, whereas continuous, okay, the event can also whatever the experiment that you do, okay, can take continuous number or decimal places 1.1, 1.2, 1.3. Okay, so that is the main difference. So under continuous distribution, we will cover the normal distribution in your syllabus. Okay, so if you look at the syllabus, it will cover from chapter number 5 under continuous. So this normal distribution, okay, so chapter 9, sampling, confidence interval, these are all related to normal distribution. Okay, so just to give you an idea of how the syllabus are designed. Okay, so chapter 4 that we are discussing this week and also next week will focus solely on the discrete distribution. So only one chapter is discussing on discrete. Okay, so the number of students in class, the number of children in a family, the number of cars entering car wash. So these are all exact numbers. Okay, so the one that, okay, again under this discrete distribution. Okay, and then versus the opposite of discrete, which is continuous random variable. Okay, so it can take the decimal places. Okay, the length of song, so 1.2 minutes, 3.2 minutes, 4.5 minutes. Okay, the weight of student, so the weight of the student can be, okay, it can also take decimal places, 45.6 kilogram. Okay, 52.3 kilogram. Okay, the temperature outside. Again, these are all numbers that can assume decimal places. So as long as the event, the value or the variable that you are referring to can take decimal places, so that will fall under continuous random variable. If the variable can only take exact numbers, the number of children, the number of rooms in a house, okay, the number of cars on the road, so those are all exact numbers. Okay, so that is the difference between discrete and continuous random variable. Okay, so whenever you do an experiment, okay, just like tossing the coin 3 times just now, okay, just like in chapter number 3, okay, you can calculate the mean and also standard deviation of a series of numbers. Okay, so it's the same thing here. Okay, whenever we perform an experiment, okay, from an event, I mean from an experiment, you can also calculate what is the mean of the probability distribution. Okay, and also what is also the variance and standard deviation of that experiment. Okay, so that's why we learn the simple approach of calculating mean and standard deviation. What is mean? Okay, what is variance? Okay, measure of the spread of your data, the dispersion. Okay, so whenever you do an experiment where you can calculate what is the probability, okay, the mean of a probability distribution is obtained by the summation of x, okay, random variable x multiplied by the probability of x happening. Okay, and then you take the sum of all the possible outcome, just like the tossing the coin just now, you will get what the mean value. Okay, so for example, this is a simple probability distribution. The probability of selling cars on a particular day. Okay, so this is again just a simple experiment. So probability of selling 0 cars, okay, 0.1. Probability of selling 1 car on a particular Saturday is 0.2. Okay, until if you can sell 4 cars, is 0.1. Okay, so in a car shop, okay, in a second car shop or company, so you can imagine the kebarangkalian or the probability of selling 0 car in one day, in one particular Saturday, or 1 car, 2 cars, 3 cars, or 4 cars. So this is the associated probability for each of these event. Okay, 0 car, 0.1, okay, and the sum is equals to 1. Okay, so the formula for the mean is simply x multiplied by px, and you sum all of the possible outcome. So x is this one, this is the x, this is px. So x multiplied by px, okay, plus x multiplied by px plus x multiplied by px. So you repeat the summation for all possible outcome, then you can calculate what is the mean. Okay, so the mean here from this simple example is 2.1. Okay, so here of course you need to calculate this manually in your calculator, because I don't see how the online calculator can do this. Okay, but should be no issue. Okay, previous students, when learning face to face, they don't even use online calculator. So certain calculation you need to do manually in your calculator. Okay, whether your laptop calculator or your own actual calculator. Okay, so the mean is basically the sum of X multiplied by PX. So for that particular event, selling cars on a particular Saturday, the mean will be 2.1, meaning 2.1 cars. The average value will be 2.1 vehicles sold. Okay, so this is the mean value of that particular Saturday. The mean value of selling vehicles on a particular Saturday is 2.1. Okay, so the same as before. Okay, when you calculate the mean, you can also calculate the measure of dispersion, which is the variance, and also standard deviation. Okay, and take note that whenever you talk about probability distribution, we always refer to this as the population symbol mu, and also sigma squared, meaning the formula for the variance. Okay, we don't use S squared, we use sigma squared, meaning the notation always refer to population symbol. Okay, so here is the formula for variance is summation of X minus mu squared multiplied by the probability of X. So here again, you are looking at the same data just now, X and PX. Okay, and from the previous calculation, you know that the mean is 2.1. Okay, so the mean is 2.1. So X minus mu 0 minus 2.1, you repeat the process for all the possible outcomes until 4 cars, and then square this value. And then from this, you multiply with the probability of X, 0.1 here. So 4.41 multiplied by 0.1, you get 0.441. So you repeat the process for all possible outcomes. The sum will be the variance. Okay, and as usual, standard deviation is the square root of variance. 1.29 square root will be 1.136. So this is a simple formula or simple approach how to calculate the mean and also the variance and also standard deviation from a probability distribution. Okay, so again, the mean is just the sum of X multiplied by probability of X associated with each of the event. The sum will be the mean. Okay, and then the variance will be this formula, X minus mu squared multiplied by Px. Okay, so you will get 1.290. Okay, as the variance. So by default, the formula is for variance. So once you get variance, you can take the square root of that to obtain the standard deviation. Okay, so that will be the formula or the solution for mean and variance for a probability distribution. Okay, so for next Thursday, okay, next Thursday we're gonna discuss on binomial first, okay, and then on the following week we're gonna cover on Poisson, okay, and we see whether we can finish chapter number 4 by next Monday, or if not, maybe we need to continue until next week Thursday, because the plan is in terms of the total learning time for chapter number 4 will be 6 hours, meaning for 2 weeks. Okay, but again, if the chapter we can finish earlier, then we can have more time for a much harder syllabus, meaning the topics later in the syllabus after the mid-semester break. Okay, after especially topic number 8, okay, 7, I think require more time, okay, in terms of the teaching. So I think for chapter number 4, hopefully we can finish by next Monday. Then we can start on chapter number 5, okay, by next Thursday. Okay, so I think that's it for today. Okay, I don't want to do any exercise yet for chapter number for this particular part. Okay, you can refer to the book in your ebook. Okay, but then I think since the focus is mainly on binomial and Poisson, so I will focus more on that next Thursday. Okay, any other questions? So before that, okay, please do practice this thing again. Okay, from any question from the book, whether from the one with answers or the one without answers, you can compare your answers with your friends. Okay, since you are using the standard direct method from the calculator, so there should be no difference in terms of answer lah, because what you do is just key in the data from your textbook, okay, directly into the website. So there is no, supposedly no margin, there is no error that will come from your side. Okay, so I think that's it for today. Okay, inshallah,